Welcome back, friends. Let's take another example on mechanical energy in an isolated system. So this is the question: a human cannonball in the circles is shot at speed of 21 meters per second. So speed is given to me 21 meters per second with the horizontal at an angle of 20 degrees above the horizontal. So third angle given to me is 20 degrees. Sorry. And uh, and it is at a height of 15 meters above the ground. So height is given to me 15 meters, and then if the acrobat has a mass of 56 kgs, the mass is given to me, which is equal to 56 kgs. And what is the gravitational potential energy relative to the ground? I wanted to What is the gravitational potential energy relative to the ground when he is at the highest point of the flight? So we wanted to find the gravitational potential energy at this point. So to find the gravitational potential energy means the potential energy at this point. What we can say, if this is an isolated system, as I said, this is an example of isolated system. So this is the mechanical energy at location 1, and then this will be mechanical energy at location 2. And for an isolated system, mechanical energy at location 1 is equal to mechanical energy at location 2. So if I can find the mechanical energy, which I can use to find the potential energy at location 2. So that's how we will solve this question. So let's look into this question. So first of all, mechanical energy at location 1 will be equal to kinetic energy plus potential energy. So this is equal to half mv square plus mgh, which is equal to 1/2 times, this is 56 times, 56 times 21 square plus 56 times 9.81 times 15, and this value will come out to be 20588 joules approximately, mechanical energy at location 1. Now the mechanical energy at location 2, as we said earlier, will be equal to the mechanical energy at location 1. I should write it MEL2 is equal to MEL1. So this is equal to ME at L2 is equal to, again I made a same mistake. L2 is equal to 20588 joules, and which is also equal to potential energy plus kinetic energy. So now this becomes a little tricky here. What is the kinetic energy at this point? So the kinetic energy at this point, because this human cannonball is still moving in the forward direction. If I emphasize on this one here, this person is still moving in the forward direction. So there is kinetic energy, but there is no vertical component. Let me change the color. So there is no vertical component of this velocity, only the horizontal component of the velocity. And if we can recall the concept of the projectile motion, the horizontal component of the velocity does not change with time. So it will remains the same as that of the initial value. So what was the if I can find this value, I'll be able to find the horizontal component of the velocity on top also. So the horizontal component of the velocity will be v cos theta is equal to vx, which is equal to, this is 20 times angle given to us. If I go back, angle given to us is 20 degrees. So v cos of 20 degrees, it is 21, not 20, equal to vx. So 21 cos 20 is equal to 19.7 is the value of horizontal component of the velocity. And make sure when you are solving these questions, your calculators are in degree mode, not in radian mode. Students end up making a mistake a lot where their calculators are in degree mode, and then they end up messing it up. So plus kinetic energy is equal to, how can I find the kinetic energy? Now I have the horizontal component. So half time mass is 56, mass does not change, times 19.7 squared. So 19.7 squared times 56 times 0.5, which comes out to be, this value comes out to be 10866.5. And this is potential energy equal to potential energy. Let me make some space here. I'm gonna erase this, and now this is the mechanical energy, 20588. So potential energy value will be 20588 minus 10866.5. So 20588 minus answer, it comes out to be 9721 joules, 21.5 joules approximately. That is the potential energy which we've calculated, this many joules. So we've solved for the first part. So part A, we've solved it. Now let's look into the part B. So if the net in which he lands is 2 meters above the ground, how fast he is traveling when he hits the ground? So this is really important. So I'm gonna draw it one more time here. So let's draw it here. So he started here and he lands 2 meters above the ground. That's what's happening. So usually what the students think, sometimes they think that when he touches this net here, his velocity becomes 0 because now he will come to the rest. But that does not, we don't solve the questions assuming the thing is going to come to the rest. What we do is we assume that he is about to hit the ground whenever, rather than taking the value as he hits the ground and the velocity comes to rest, we consider it as he's about to hit the ground. He's ever so slightly close to the ground. Now let's solve this problem. So mechanical energy here at location 3, will also be, what will be the value? 20588. That's the value which we figured out, this much joules. And here the potential energy value will be equal to mgh, and mgh means this is mass is 56 times 9.81 times 2 meters. So let's calculate this value. 56 times 9.81 times 2, which comes out to be 1098.7 joules. That is the potential energy at this point. Now the rest of the energy will convert into the kinetic energy. So mechanical energy equal to potential energy plus kinetic energy, and the potential energy is 1098.7 plus kinetic energy, and the mechanical energy is 20588.7. so 20588.7 minus 1098.7 equal to the kinetic energy, and 20588.7 minus answer, that's gonna give me 19489.9. yeah, that's 98 joules kinetic energy. So that's the value of the kinetic energy. And what we wanted to do, how fast he is traveling when he hits the ground. So do I wanted to find the kinetic energy? No, this still question is incomplete. I wanted to find the velocity with which he hits the ground. So kinetic energy is equal to half mv square, so which is equal to 19489 point, I'm gonna call it 98. I'll take the approximate value. So this is equal to 1/2 times 56 and then velocity square, and then this value divided by 56 multiplied by 2, that's gonna give me 696 velocity square. And if I square root this value, that comes out to be 26 point approximately 4 meters per second. That is the velocity with which he will hit this net here. So hopefully you were able to understand how to solve the questions on mechanical energy of an isolated system. I'll see you soon with another